Starting recording. Is it recording? Yeah. Okay, you're being recorded. Okay, let's go.
Okay.
Recording. Okay, so let's say, hang on, let me clear the board. Can you see what I'm writing?
Yeah.
Yeah. Okay, so let's say you've got a sphere of radius 10. Okay, what's the biggest cone that you can fit in that sphere? So, for example, you can have a cone. So a radius of 10 means negative 10 here, 10 up here, and then you've got 10, 0, 0, negative 10, right?
Uh-huh.
So you can have a cone where it looks like this. You see that? What's the biggest cone that you can fit inside that sphere? Or you can try and fit this purple one here. Can you see that?
Mm-hmm.
And it goes through this point here. So let me redraw this vertical line. So I'm going to redraw the vertical line. So it looks like something like this. Or you can have a cone that looks like this. So looking at this diagram, which cone do you think, just by first glance, which cone do you think has the biggest volume?
Biggest volume? I think it's the pink one.
Yeah. Okay. Yeah. So it seems like the blue one has a small volume. The green one's quite big, but just by glancing at it, the purple one seems to be the biggest, right?
Mm-hmm.
But your job is to find exactly what exactly the vertical height, the base, the radius of the cone, if you like. So what's the biggest cone that we can fit within that sphere? So how do we go
The
about?
green one?
Yeah, but which one's the biggest?
The pink one?
Yeah, the pink one. But we need to find the vertical height, the dimensions of that pink cone. So how do we go about doing this? Do you know the formula for a volume of a cone?
Volume equals base times height times length. Width.
What do you mean? So you've got a cone here like this. Do you know the formula for a volume of a cone?
Base times height times something else. I can't remember.
Okay, so sorry, say that again, Chelsea.
Volume of a formula is length times width times height. No. It's area of the base times height.
No. Okay. So the volume of a cone is like this, Chelsea. Jump back to I drew. It's like a third of a cylinder for some strange reason. Is a third of a cylinder. So how do you work out the volume of a cylinder? What do you need to know? What do you need to know in order to work out the volume of a cylinder?
The base length.
What do you mean the base length?
The length from the left of the base to right of the base.
Okay, so you mean this diameter
From
here?
here to yeah.
Yeah. What about it?
You need to know that and the height.
Okay.
Height.
Yeah.
And the width.
What width?
This width.
Isn't that the height?
The height. Sure.
No. Well, wait. If you get that green length times the height, you're going to get like a square thing, right? So that's not volume.
Then
That's
you
like
find the. I don't know then.
wait, Chelsea, you should know the formula for the volume of a cylinder because you've got to work out the area.
The area.
Circle,
Oh yeah.
of the circle. And once you've got the area of the
You
circle,
find out the height.
yeah, you drag it all the way up, so it sweeps up the whole volume. How do you find out the green? What do you need?
You use the formula of area.
Yeah, which is what?
A equals
Times.
pi r squared.
Yeah. So basically, you need to know the radius, right?
Yeah.
So what? So it's really. So what's the formula for the volume of a cylinder? V equals what?
Um, V equals uh the radius
Yeah.
or
What about?
the area of the
Yeah.
circle.
Which is what? Which is what?
Um, pi r squared
Yeah. So that gives you the area of the circle, and then what? What do you need to know about?
times the height.
Yeah, times the height. Okay. So
Uh,
so you need to know the height of the cylinder. Well,
oh
the
wait. So if it was the triangle thing, it would be pi r squared h over 3.
yeah, a third of that cylinder. And then if you punch in, if you search volume of a cone, go and punch it in into Google, volume of a cone.
Oh.
Yeah, that is what we've done. So it's basically a third of a cylinder for some strange reason, which we won't get into. Okay.
Mm-hmm.
So the volume of a cone is given by pi r squared h over 3. Um, so that will give us a volume. We want to maximize the volume, but the thing is, it has to be contained within that sphere. So this is the hard part. You've got a sphere of radius 10. Okay.
Okay.
Um, the hard part is in how do you set the problem up in such a way that it has to be contained within that sphere.
You put a into it, so then if you put into decimals, you can stretch it out.
Okay. Well, whether we need the formula for the circle. What's the
Pi r squared.
that would give us the area of the
Oh,
circle.
our
Oh,
circumference is 2 pi r.
yeah, circumference is 2 pi r, but I want to know the equation of the circle of radius 10. So if you were to jump to decimals and punch in, well, how would you draw a circle radius 10 in decimals?
Radius 10
Yeah, I want you to draw a circle radius 10 in decimals.
2 r 2 pi 10
So
20
where's our
pi.
so where's our circle?
Hold on. Okay. I don't know.
So where's our circle? I want to draw a circle radius 10. Where's our circle?
uh,
So so the equation of a circle is x squared plus y squared equals the radius squared. In our case, is 100.
what did you
So
say?
what that
X squared what?
yeah, um, equals 100.
Oh.
Okay,
Okay.
so that will give us a circle radius 10. What happens if I want a radius of 4? What do I do?
You put 4 into the x and y?
No. Well,
Hey,
try.
no, no, no.
I now want you to draw a circle radius 4.
4.
If you look at it, it's radius of 2. Well, the
Oh,
equation of a circle is x squared plus y squared equals r squared. So if you want a radius of 4, you have to square the 4, meaning 16.
oh,
Yeah.
oh.
So let's put it back to a radius of 10. Yeah. Okay. So jump back to I drew now. We want to set up a machine somehow where you have one variable, Chelsea, and for this given variable, it has to spit out the volume of that cone, and we want to maximize this v here. Okay,
Okay.
so you need to come up with a cunning variable. What can you vary that will allow you to scan through the whole system? Do you
A.
understand?
You
Yeah, but then what does that a represent on our diagram
um the length
of what?
Of the circle?
The length of the circle,
Oh
like
no, the length of the yeah.
like oh, you mean the circumference of the base of the the cone?
Sure.
But that's not very good because even though you can do that, there's an easier way, Chelsea. If you call this length A here, Chelsea, so
Mm-hmm.
suppose so you can scan A. So suppose A is like here, right, Chelsea?
Okay.
Then that will then allow us to draw this cone here. You see that? So
Okay.
A. So in our case, what's the domain for A? So
A.
can A can scan through the whole system because look, if A is down, if A is up here where it's let's say at 3, then our cone would be like this. You see that?
Yes.
If A is at so if A is 0, where would that be?
Right here.
Yeah. So that would give us this this cone here. Okay.
Okay.
So so the clever part is in setting up this variable that can allow you to scan through the whole system because look, A can vary up here, down here, all the way up here. So what's the domain for our scenario, for our problem? I need to know the domain for A.
A
Can A
can
be
be anything um anything over -10.
okay, anything? So A can be
A can
above
A can be
negative 10.
greater than or equal to -10.
Okay, can it be dead on negative 10?
Yes.
What would be the volume when it's dead on negative 10?
Um. Uh. I don't know.
Um,
Here.
suppose you're slightly above negative 10, Chelsea, slightly above. So you're gonna have like a really thin cone. You see that?
Uh
A
huh.
really when you're dead on when you're dead on 10, there is no width to your cone. There is no base. So if there's no base, there can be no cone. So it's pointless having
Um.
a negative 10.
Um.
You're not
A
gonna have a
can only be greater than -10.
yeah,
Oh.
right?
Okay.
So can A be 87?
Uh. No. A has to be greater than -10, but less than 10.
Can it be dead on the number 10?
No.
Okay, so that's our domain. You see that for our problem.
Uh
So
huh.
anything 10 or below negative 10 is just meaningless. We can forget about it.
Okay.
Okay, Chelsea. So
Okay.
for given A, you have to be able to tell me the volume. We need to come up with a formula for the volume for given A. Suppose A is 0, Chelsea. What would be the volume?
Um.
So if I put 0 into the machine, what
1.
volume? The volume would be 1.
No. 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 It would be
If I put 0, if A
uh
is 0, whether if
1. No. Wait. Let me think.
okay,
0, 3. I don't know.
okay,
What
if A is
am I
0,
putting 0 into the V?
no, A is 0, meaning when A is 0, it has the base of the cone would be right here at a height of 0. Can you see that?
Wait. Oh.
So
Okay.
so A is at 0. Can you see that? At a height
Okay.
of 0. Okay.
Okay.
So when A is 0, what's the volume of that green cone? So we want to set up a machine where if I put in a 0 into the machine, it must be able to tell me the volume. So I'm asking you, what's the volume of that cone?
Um.
What's it
Um.
when A is 0? What's the volume? There is a
uh
volume. You see a cone.
Volume of 10.
No.
I don't know.
Okay. So you've got that cone there. You've got to work backwards. What do you need to know in order to work out the volume of this cone? What do you need to know?
The height.
The height? What's the height?
I don't know the height. 10.
Yes, 10, because if A is at 0, then the height must be 10,
Okay.
right?
Okay.
So we know the height is 10. What else do we know?
The area of the
So
circle,
we know the height is 10. Okay,
10.
what else?
We need to know
Yeah,
the area of the circle.
what's the area of the circle?
Um, Let me think.
Yeah, you need to know the area of the circle. But,
100 pi.
actually, yeah, it's 100. I think it's 100. Well, you just need to know the radius of the circle. Then it's pi r squared. What's the radius of that
10.
circle? Yeah, 10. So you're right. You put 10 into here. But basically, you can put 10 into that r there, and you know the height. You see that, Chelsea?
Yeah.
So theoretically, you know the volume of that green cone. All right. So now suppose A is at 3. So so when A is at 3, can you see that number 3 there?
Yeah.
Okay. What's the volume of that cone now?
Um, Wait, what's 3?
Can you see that 3 when A is 3? When A is 3, what's the volume of that cone, that purple cone now?
Um, the height is
What's the height?
7,
Yep, the height is 7.
and
And
then
then what? The radius. You need
the radius is 10, so then the area is
no,
100.
10, Josie.
No?
If the cone is down here, then the radius is 10. When I move up to a height of
Oh,
the radius is
um,
smaller. What's the radius?
I don't know. Um,
Oh, okay. Let's set up this in decimals so that we can slide
okay.
A up and down, and then it's going to draw um, our cone. Okay.
Okay.
Right up. Before we do that, go back to decimals, not decimals. Okay. Suppose A is at 3. Can you see? We need to know this point here, Chelsea.
Pardon?
You need to know this point so that we can draw a line from here to here.
It will be 0. No, 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 no. 10,
We need
0.
no, no, the
No.
coordinates would be no, it won't be 10 0.
It will be
The
0,
coord
0 first, right?
no,
No, no, no,
no,
no,
the
no.
would be this much across and this much up. We need to know the coordinate of that point.
10, 0.
No, 10 0 is
I
right
mean,
here.
10, 10, 3, 10, 3.
No, 10 3 would be you moving all the way to the edge and then up 3. There, you
Oh.
missed it because
Um,
the radius is smaller. We want to know
oh.
the of that point.
Do I need to find the
Well,
angle using trigonometry?
uh, no, you see,
Uh,
this is the beauty of having that equation, Josie.
uh,
X squared plus y squared equals 100. Remember this?
uh-huh.
So now that you know y, you can work backwards to find x, right?
Okay.
So if you put 3 into the y, that would then become 9 equals 100 plus x squared,
Uh-huh.
right?
Minus
So
9, 91.
minus that would be 91. So x would be root 91. So the coordinate there would be root 91 across and 3 up. Can you see that?
Uh-huh.
Okay, suppose it's not 3, but it's A. So what is the coordinate for that point at A?
Um,
So now it's at A. So remember, start
A.
out if you want to move
X
along the
squared
circle,
plus y squared equals 100. Put
yeah,
A into the y.
equals 100. Put A into the Y, so it'd be
A
A squared.
squared equals 100. On the left side
Yeah,
plus x squared. And then um, uh, minus a squared.
yeah. So 100 minus A squared,
And then
and
square
then
root of x.
but,
2.
but when you square root, what's the square root of 4? 2.
2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2
And
Neg 2?
Yeah,
Negative 2?
negative 2. Yeah, so you get two versions, right, Chelsea?
Oh, so square plus minus square root of 100 minus a squared.
Yeah, so it's basically plus and minus. There are two versions, meaning the positive version would give you all the x's to the right-hand side,
Oh,
like this,
okay.
and then the negative version would give you all the negative ones. But we don't really we don't really care about the negative. We just want to know the positive so that we can draw our cone. Okay,
Uh-huh.
Chelsea? So
Uh-huh.
we can discard the negative square root. Is that okay?
Yeah.
So now if you go to decimals, add your slider A.
How do I add a slider?
I don't know. You just press A, I think. Oh,
No.
uh,
Um,
add a slider.
no. Um,
Oh, well, there.
A by itself doesn't work.
There,
So,
add a slide. Yeah. Okay. So now, okay, leave that there. So now, you want to draw the coordinate. So bracket. How do I draw a vertical dot? Well, a dot that moves vertically up like this, Chelsea. Hang on. See this dot here? How
uh-huh.
do I get to slide up and down like this?
You need a point.
Yeah.
A.
Bracket, 0, comma A.
Oops. Bracket
Bracket
0, comma.
0. So 0 is like the x coordinate. A, yeah. And then you can slide A back and forth,
Yeah.
right? So that's going to
Mhm.
be our A. Now for given A, I need to know the point that we worked out earlier. What's
So do I use square root of 100 minus a squared?
that would, yeah, that would give you the x coordinate. Then what's a y coordinate?
Uh,
Hang on, Chelsea. Hang on, Chelsea. Wait up. Add in another point, Chelsea. So bracket.
bracket
Yeah. Now I want you to score the other point. Bracket
a
what?
0.
No. You need what's the coordinate of the other point? So how far to the right do you move, and how high up do you go? So set A to 3. Set A to 3. So now our cone is currently at an elevation of 3. Okay. Now
Mm-hmm.
how do we draw the other point?
Um, you do the opposite of what you did at right here.
So go and try it. What do you mean?
A
You want to?
comma 0.
That's not a point there. So slide A. You see? Yeah, it's not working, is it? I want
Guess.
it to represent that. I want it to represent that black point that we worked out earlier. All right.
Um,
Go back to line 2.
oh, you do this thing right here, square root of 100 minus a squared.
Yeah. Yeah. Because we just worked out the x coordinate for that point. But that's not drawing our point. You need brackets. So where's our point?
Oops, hold on.
Yeah, you got to get out to the square root.
Uh,
What's going on? How come it's not working? Oh, why 0 though, Chelsea? So you're saying it's an element that's
comma,
a comma.
comma, a.
Yeah, because it's A up, isn't it? Yeah.
Yay.
Okay, so now we just need to draw a line between those 2 points. So go to table, that table you just drew up there.
Okay.
Okay, so the first point would be 0, A,
0.
A, and then you're telling decimals to join it up with the point, what is it? Square root 100 minus A squared. Yeah, and 0. Ah,
A.
Yeah. And then click on that black circle for 2 seconds so that you can draw a line.
Oh.
Yeah. Go to lines.
Line.
Yeah. Okay. So now drawing our cone. That's just like half of it. Like Chelsea, where's our cone? Doesn't look like a cone.
Wait.
So go back.
It's
So
at
now I
height.
want you to do. Well, Chelsea, go back to Lightroom. I now want you to do this, Chelsea. You've done this black line here, right?
Mm-hmm.
I now want you to do this. So that will represent our cone. Do that in
The
Desmond.
negative side?
What? I want you to somehow draw that black. How do you do that?
Okay.
Because at the moment you've drawn that line there. That's just one line. What about the other line? Oh, well, wait, Chelsea, hang on. So what you do, Chelsea, go back to Lightroom. You know you started here, and then you joined it up to here. Now from here, you need to join it up to here. And then from here, join it up to here. And then from here, join it back up to here.
Mm-hmm.
Can you see that within your table? You understand?
Yes.
So how do you do it? Well, first, what's the coordinate here, Chelsea?
Let me think. That's to 10. So
Sorry?
this point all the way to 10.
Yeah. So you got to join. So you're telling it to go square root 100 minus a squared, of course. What's the coordinate of the top of that circle?
0, 10.
Yeah, 0, 10. How can you put that square root thing?
Oh.
Okay, now join it up to the other end of
And
this.
then from here to 10 to negative square root of 100.
So you're moving 10 across in the right direction, and then down that thing there.
Hold on, let me think.
Okay, so wait there. Jump back to Lightroom. Okay, I want to know the coordinate right here, Chelsea. What is the coordinate right there?
JK. Wait, let me think. Oops. Hold on. I don't know.
Give up?
No, wait, hold on. There you go.
Yeah. And then join it up to the original A.
There you go. Yay!
And then slide it back and forth.
Yay!
Okay, Chelsea. So now we've got to find an A that will give us the biggest. What's your guess, by the way? Where do you think A would be? That will give us the biggest volume. And remember, we are using 2D to represent something in 3D.
Right here.
Okay, somewhere around there, right?
Yeah,
so
negative
you think
-5.
-5. We don't know that.
Yeah.
Okay, so now jump back to I drew. So let's just say A is currently -3.
Okay.
Okay, Chelsea.
Okay.
Suppose A is -3. You have to be able to tell me the volume. What's the volume?
Volume is
Oh, yeah, what's the volume? Actually, let's do -5 because you think that's the biggest volume, right? Let's do.
okay.
So suppose A is -5. Then what's the volume? So for a given A, any A, you have to be able to tell me the volume. So what's the volume for a given
Ooh.
A? So what's the volume of this
Um.
green cone?
Oh, I meant -5, by the way, not
Oh, sorry,
positive.
sorry. What did I say?
Oh, I thought I said +5, but I meant -5.
Okay, doesn't matter. So suppose it's -5. What's the
Mm-hmm.
volume? So you've got that green cone.
Um,
What do you need to know in order to work out the volume of the cone?
the area and the height.
Oh, let's not think about the area. Let's think about the radius.
The
Even though it
radius
is,
and the height.
yeah. So what's the
Radius
height?
of 10. Height of.
No, wait. The radius is not 10, Chelsea.
Oh, no.
Just
Radius of -5.
no.
Oh.
-5 is this length here.
Radius of. Um.
What's the height first? What's the height of our cone?
Height.
What's the height?
Let me think. Negative or 10?
What? Right. The height of the cone is 10. No, 10 is from here to here.
-15. No, -5.
What? How can you have a radius of -5? What does that mean? Oh, sorry.
No, height of -5.
What does that mean? The height. You see, if a person is 1 meter tall,
Oh,
yeah, the height of -5. What's that?
um,
Imagine you've got a person here that's located at -5. What's the height of that person? What's the height of this person, Sophie?
um,
Basically, what is this height here? That's the height of a cone.
10 plus 10 plus something.
Yeah, what? What's the height of that cone?
10
10 is from here to here.
plus -5.
10 plus -5. What does that mean? 10
6.
plus -5. That gives me 5. How can that be 5?
I don't know.
Come on, what's the height of that cone?
Um, okay, let me think.
You're at a location of -5, but I want to know the height of that cone. You see, if you're at 3, if you're at a height of 3, Chelsea, I can work out that the height of the cone is 7, right? Can you see that, Chelsea? Can you see that?
Okay.
Can you see if you're at
Yeah.
a location of 3, the height is
Yeah.
7. If you're
Yeah.
at a location, say 2, if you're at a location of 2,
8.
what's the height of that cone?
8.
What's the height of that? 8. Suppose you're at a location of -5, what's the height of that cone?
I don't know.
Okay, then get this length plus this length. Okay, what's that blue length there? That thick blue length.
-5.
No, what's the length? How if I
5.
would yeah, the string would be 5 meters long if you like, right? You can't
Yeah.
have a string -5. And then from
Yeah.
here to here is 10. So you know the
Yeah.
length is 15.
I said 15 before.
When did you say 15?
Ages ago, I said 15.
Well, we've got this on recording,
Yeah.
so
If you
so
want.
everyone's gonna back me up. Andre, when did you say 15?
Ages ago.
Well, we got it on recording. I'm sure the viewers will side with me
Yeah,
there,
I'm
Joe.
sure you're
Okay,
two
okay.
viewers.
So let's change this then. Let's just say we're at -3. So what would be the height of this of this cone now? Suppose we're at
13.
sorry,
13.
13.
Oh,
Okay,
I
so
think I said -15, and that's why you said no.
oh yeah, probably, yeah. Anyway, suppose I'm at -3. What's the height?
Height 13.
The height is 13. Okay. Suppose I'm at A. What's the height?
A plus 10.
A plus 10. So suppose I put a -3 into this A here, right? -3. That would mean
Negative A plus 10.
yeah, -A plus 10. Yeah. So I'm going to rearrange it. So you're saying -A plus 10. I'm going to rearrange it as 10 minus A. Is that okay? It looks
Okay.
neater. So the height, strangely enough, is actually 10 minus A for any given A. Okay. Well, anyway, so let's go back to it being -3. So we know the height is 13. Okay. What's the radius of that circle? We need to know the radius.
Do I use trigonometry?
No, that you see, you want to jump to the circle, right?
Okay.
Anytime you think about the circle, think about x squared plus y squared equals 100. This thing here will govern the circle. So so if you're at -3, how do you work out the red distance here, which represents a radius of a cone, the radius of a circle? How do I work out that red length
Thinking.
if I'm at -3? Well,
Pi r squared.
no, put
-3 into the y, and you
and then
solve
work
for x.
that. Yeah. So tell me what to do.
So it
that
will
would
be
be
x squared plus 9 equals 100. And then
equals 100.
subtract 9,
Yeah. So
91.
x root 91.
Mm-hmm.
Yeah.
Mm-hmm.
By the way, this length here is root 91, right? And then if you look at the height of +3, Chelsea, can you see that it's also root 91? They're both the same.
Yes.
Can you see that? Does that make sense?
Yeah, it does. Yeah.
Anyway, the radius is root 91. So when you're at an elevation of -3, what's the volume of that cone?
Volume is pi
Yeah.
square root of 91 squared.
Oh, wait. Pi
Square root of... Oh, no, just 91, because the squared and the square cancel out.
Yeah. So 91. So pi
Times
91
height, which is 13. So pi 91 times 13.
over 3. Okay.
Times
So
the
now,
91 and 13. Oh, okay.
yeah, whatever it may be. So now for a given A, remember we want to try and create this machine where I feed you an A, you have to tell me the volume.
Oh, you put A into the y.
Anyway, so given A here, I want the volume equal something involving the A, Chelsea. So what is that? So for given A, you have to tell me the volume. So what is it? What's the formula for the volume for given A?
Pi.
Well, wait, Chelsea, you got to start here. You need to know the volume of that cone. You got to work out the height. What's the height of this cone for given A?
A plus 10.
A plus 10. That's not what you said. Earlier, you said 10 minus A for some strange reason.
10 minus A.
Yeah. So the height is 10 minus A. Now what?
You find the radius.
Okay, what's the radius?
Pi A squared.
No. You basically
squared.
You basically want to know this length here, that red length.
A divided by 2.
A divided, no. You managed to work out this length earlier for given
Yeah.
A.
I forgot
How
the
do you?
formula I used.
Okay,
Square root of 100 minus A.
Well, wait. Start again, Chelsea. Just to play it safe. Let's put this into the X or into the Y, Chelsea. Which
Why?
one? Because I'm asking you to.
Why? No, you put it into the Y.
Okay, you put into the Y. So this thing here would be X squared plus
Square root of 100 minus A squared.
square root of 100 minus A squared. Yeah, that's right. Yeah. So the radius is, what did you say? Root 100 minus A squared. That's the radius there. Okay?
Yeah.
Well, I'm after the volume of that cone. What's the volume of that cone?
Volume of triangle is pi.
Oh, cone you mean, not triangle, cone.
Or same thing, yes.
Okay.
Volume is pi times square root of 100. No. Volume is pi times 100 minus A squared in parentheses. Times 10 minus A.
In parentheses. Yeah?
Yes.
And then you're done, right?
And then you solve it.
It's always a third of a cylinder, Chelsea.
Divided by 3.
Yeah, divided by 3. So that's the formula for a volume for any given A.
Okay.
Right, Chelsea? So
Okay.
if you punch that into DESI and then scan A for the biggest volume.
Pi.
Oh, yeah, that's right. Yeah. So for any given A, you can work out the volume. So punching the formula, that's not right. It's got to be within. Don't forget to divide it by 3. Okay, so you've got a volume of, just scan around, look for the biggest volume.
I think this is the biggest right here.
Somewhere around there, is that?
Yeah, I think
So
so.
what is that? Negative 3 point.
Negative
3.4. All right, jump back to writing.
Negative
So
3.4.
the Chelsea guess is what?
My guess was 5.
Oh yeah, but from our experiment,
Negative
it was
3.4.
negative 3.4. Okay.
Uh-huh.
So now we can use calculus to calculate the location precisely. Okay. Well, Chelsea, well, wait, hang on. Draw a graph of what this thing will look like. Okay. So
Draw what?
graph. Yeah. So you've got V versus A here. You see that?
Okay.
Oh, wait, there. It should be like this. It should be negative. Like, wait, negative like this. V versus A. A volume for any given A. No, it doesn't look like that, Chelsea. Because this is like a graph. You see what I mean later, Chelsea. It's not a triangle. Wait there, Chelsea.
Okay.
It's not a triangle. Wait there.
Okay.
All right. So I'm going to.
Okay.
Let me just move this up there. I'm going to show you what this graph is doing.
Okay.
Okay. So I'm going to rewrite it like this. Pi over 3 is just a number. Pi over 3 is just a number. It's a constant, right?
Okay.
It's just like the number, I don't know, 7. It's just a number. This is just a number.
Yes,
Even though
yes, I
there's
understand. Yes, I understand.
all right. So wait there. I will show you what this graph will look like. So now multiply this out for me. It's just one block multiplying another. So what does that become? Chelsea?
Pardon?
This times this.
Oh,
This times
Alexa, 100 times 10 is 1000.
1,000.
Yes, 1000.
This times this.
Negative 100a.
Negative 100a. This times this.
Negative 10a squared.
And then this times this.
Plus a to the power of 3.
A to the power of 3.
Is
Okay,
that
Chelsea?
okay?
Right. So
Ew.
hang on.
Why is the parentheses so
Oh,
small?
what, you
Ew.
want curly ones? You want round ones? Like this? Are you happy now?
No. Ew. I like brackets, but why was one smaller than the other?
What difference does it make? Okay, anyway,
You are what you write.
anyway. So now, Chelsea, I'm going to rearrange this because I know you're going to start flying the way it's. So it's going to be A. I'm going to rewrite it like this: minus 10
Oh
A
yeah, that's
squared
fine.
10. You're
That's
much happier now.
100a
Plus
plus
1,000.
1000. Yeah.
Okay.
Mhm.
What is this graphic? Oh, if I were to ask you before this, y equals x squared, Chelsea, it will look like this, right?
Yeah.
If I stick a
Oh,
number,
this is my favorite. A to the power
yeah,
x to the power of
well,
3.
wait. If I stick a 7 in there, it just makes the graph steeper, right?
Yes. Mhm.
So if I stick like pi over 3 in front of it, it's just going to look steeper. That's all it is. Because
Okay.
this pi over 3 is just a constant, right?
Okay.
It just makes it slightly steeper. So anyway,
Okay.
looking at this, if I were to ask you to sketch y equals, looking at this here, Chelsea, if I were to ask you to sketch y equals x to the power of 3 minus 10x squared, are you still there, Chelsea?
Yeah.
Okay, plus 100. What does this graph look like?
Well, first, x to the power of 3.
Yeah, when it's big, it wants to do x to the power of 3, right? So x to the power of 3 looks like this,
Yes.
only when it's big. Okay, so your graph will want to do something like this.
Uh-huh. And
Can you see that?
then,
Can you
mhm.
see that? So weather, but only when it's big. So we know it's going to do something like this. Only when it's big. So, can you see that, Chelsea?
Yes.
Okay. So when it's small, it wants to do this. What does that look like? An intercept of 1,000, a gradient of negative 10. So your intercept is 1,000 here, and it wants to do a steepness of negative 10. So it's going downhill like this. Can you see that?
Okay.
Yay or nay?
Yeah. Yeah.
Okay. So there is something happening in between with this x squared thing, but we don't know.
Bless me.
Anyway, what does that graph look like then, Chelsea?
Looks like this. Let me draw it.
Oh, nice drawing. Yeah. Okay. So I'm going to
Or
read.
like, more like straight, but like.
Yeah. So I'm going to redraw it. It looks something like this. I don't know what it looks like, but it maybe looks something like this. I don't know. Right,
Yeah.
Chelsea?
Mhm.
So basically, with this pi over 3 in
Makes
front
it
of it, it just
steeper.
makes it steeper. But who cares? We only want to know the general shape of it.
Okay.
Okay, Chelsea? So
Uh.
basically, this graph here, V versus A, V is our vertical axis, A is our horizontal axis. Okay?
Okay.
So for any given A, we know the volume. You see, our graph actually looks like this. Earlier, you thought it was some sort of triangle, didn't you? Remember that?
Huh?
Chelsea?
What?
Earlier, you thought it was a cone, didn't you?
Yes.
Yeah, it's actually just a curve like this. Basically, what part of that graph are we interested in?
um.
Are we interested in This point here?
The top part. No. The top
This
part.
one here, biggest volume.
No, the other top part.
What other top part? This top part here.
No, the left hill.
Oh, this one here. Why this one? You want the biggest volume. Well, so why don't you select this one up here? You want the biggest volume, right? So you want the
Yeah.
highest. Why do you choose this one and not up here? Because this
Because
graph goes.
that one doesn't have a limit.
What do you mean it doesn't have a limit?
It
What does
just
that mean?
keeps going, so we can't find the definite
Yeah,
volume.
no.
I don't know. I'm not sure.
You know why?
Why?
It turns out that our domain, let's say 10 and -10, I don't know where, but you see, beyond that thing, it's really beyond our domain, Chelsea. You remember our domain right from the start?
Uh,
Right from the start, our domain was -10 to 10, right?
okay.
So it's pointless looking for this point because it's beyond our domain. For example, what's the point of having an A at 11, Chelsea? Look at our diagram. 11's up here. Can you see that, Chelsea?
Yeah.
It's not even in our sphere. When A is 11, it's meaningless. Chelsea,
Okay.
you understand? Yeah, or nay?
Sure.
Well, it's just like 11 being here on our graph. This bit here is meaningless. It
Why?
means, because it means that our cone is that our array is beyond our sphere. It's not
Oh,
within us.
is it because we set a limit?
Well, we said it has to be within the sphere.
Okay.
A has
Yeah,
to
yeah,
be,
I understand now. Yeah.
yeah. So what's the point of looking for a graph that's somewhere out here, somewhere beyond our domain? Because it's only meaningful in our situation when it's between -10 and 10. Can you see that?
Okay.
Chelsea?
Uh-huh.
Anyway, between 10 and -10, can you see that we want to find this point here? So you were right. Can you
Yes.
see that?
Mm-hmm.
Okay, how do we find that point? The highest point. What's so
Uh,
special?
well, the height is
Well, I want to. How do we
10.
find the highest point?
It's 10 because that's our domain. That's our limit.
No, no,
10.
that's not the course. The course is 10, Chelsea. And don't forget, this is 1,000. The intercept is 1,000.
Um,
How do I find this peak, the highest point? How do I find
you put
the
it
top of,
into the formula.
put what into the formula?
You
No,
put
you got to use formulas,
um,
Chelsea.
you
Chelsea, you
use
got to,
calculus.
yeah. What's so
Yeah.
special about that point?
Um,
How do you find the highest of a curve or the lowest of a curve? What do you do? We've done it
you
before.
use calculus.
Yeah, but how? What? For example, I could give you why.
Differentiate.
Yeah, you differentiate it. Find out when the gradient will be zero. Because at
Yeah.
the highest point, the gradient is zero.
Yeah.
It turns out that this also has a gradient of zero as well.
Okay.
So how do you differentiate this, Chelsea? You basically need to
Please.
find dv over dA. Can you see
dv
that?
over dA is 3a
Oh,
squared.
wait. See that constant there? You've got to leave
Yeah.
that constant one
Oh yeah. Okay.
and concentrate on differentiating
3a squared
3a squared
minus 20a
minus 20a
minus 100.
minus 100. Yeah. Okay, Chelsea.
Okay.
Hang on, let me look at my notes. Where is it? Uh, okay. Yeah. So now, Chelsea. I think. Hang on, let me look at my notes. Is that right? I can't find my notes, Chelsea. Well, anyway, we can find an A where and then what do? We set it to zero, right, Chelsea?
Yes.
Yeah. you set this to 0, and then what do? You've got to find an A where the gradient is 0. So what do? I'm going to set this thing here to 0. Now what?
Wait, what are we trying to get alone?
I'm trying to, well, we are trying to find a value of,
Wait, why did we set it to 0?
because we want to find out when the gradient is 0.
Oh,
Because that's
okay, yes. Then you set it to 0.
So set this whole thing here to 0 and find a
Yeah.
value of A that will tell us where the gradient would be 0.
So you
That's
would
why we set this to 0. Work backwards to find A. Find an A.
times 3.
Yeah, times 3 divided by, well, basically, let's divide it by this number, that weird number. It's just a number. It's a
Okay.
constant, right?
Okay.
So what's 0 divided by this number here?
Pardon?
Well, what happens if I divide this by...
The left hand becomes 0.
So the left-hand side becomes what?
0.
Yeah, 0. And then it basically becomes this. Minus 20A minus this thing here.
Mm-hmm.
Right?
Add 100.
No, remember.
No. You
This is
factor.
Yeah, this is like the completing the square thing.
Yeah.
Okay, so wait, you want the coefficient? Oh, this one here, I don't think it factorizes neatly. I don't know if it factorizes neatly. It might not. We don't know. Otherwise, we're going to spend ages trying to factorize it neatly when it might not even factorize neatly.
Okay.
Right.
So
let's divide everything by 3. Is that okay?
Okay. So then it will be a squared.
Yeah.
Minus 20 over 3.
Minus, divided by 3. So it'd be like this. 20 over 3
A. Yeah, I just said that. Minus 100 over 3.
Okay, now
You
the square. Can you remember how to compute the square?
you do parentheses.
Hang on.
Minus.
Wait, hang on. 3. So completing the square, before we do this, let me give you this to you. Complete the square on this. X squared plus 8x minus 1. So how do you complete the square on this?
X minus 16.
No, it's always
64.
No.
Or 4.
Yeah, but then what?
Minus.
No. No,
Plus.
hang on. You've forgotten how to complete the square.
No. Plus 64.
No.
Or 16, I mean. Minus 1.
No. No. Well, wait. First, you forgot the square here. Remember, completing the square, you always need the square thing here.
Yes.
So, hang on. Let me show you how to do this first. Let me remind you. So when you complete the square, your eyes has to always zoom into these two terms. It's always going to be half of this thing here.
Yes.
So it's going to be x minus 4. And then it's always going to be squared. You see
minus. Yes.
Yeah. So I'm trying to create these two terms here. But then if you look at this, it's actually, if I multiply this out, it will give me x. Go on, multiply this out. What would that give you?
16.
What? Multiply
Minus.
that.
Okay.
So for example, what's x plus, sorry, hang on. Oh, go on.
It'll be 16.
Oh, yeah. No, but y plus though, Kirsty?
No, it's minus.
Yeah, minus 16.
Minus 1.
Yeah, minus 1. And then you merge these two together.
Negative 17.
Yeah. Anyway, let's go back to this thing here. It's always going to be half of this. Do you know what half of that is?
Yes.
What is it?
20 over 3 divided by 2.
Yeah, which is what?
20.
20.
That's 40 over 3.
Well, wait. Divided by 2. When you divide the fraction, it gets multiplied to the bottom.
20 over 6.
Yes, 20 over 6.
So then that's
So when you
10 over 3.
Oh, yeah. So basically, you can visualize it as 2 times a 10, and then these two, they cancel each other out. Yeah?
Sure. 10/3.
Yeah, so that would be A minus 10 over
Over
3
3.
squared, and then minus
100/9
yeah, 100 over 9, and then you carry
minus 100/3.
minus minus 300 over 9. Is that okay?
What?
I'm multiplying top and bottom by 3. So
Okay. Oh, yeah. And
these two
then it will be negative 400/9.
negative 400 over 9, 10 over 3 minus. Anyway, Chelsea, we're out of time, Chelsea, but you can find a value of A where the gradient is 0. You will get two versions of A. This A or this A here. You've got to choose the negative one. Can you see that, Chelsea?
Yes. Uh-huh.
Anyway, we call it a day here, okay, Chelsea?
Okay.
All right, bye-bye, Chelsea. How do I turn this off?
You can end the call or just press
Oh,
end recording.
and yeah, and cool. All right, bye-bye, Chelsea.
Bye-bye.
Bye.